Good afternoon. My name is Mike Johns, and I'm the Executive Director of PCI Midwest and the moderator for today's webinar. Today's presentation is sponsored by PCI Illinois, Wisconsin, PCI Midwest, and PCI Mountain States. Our goal is to bring a greater awareness of precast concrete to the design and construction communities via quality continuing education programs. Before I turn things over to our presenters, let's review a few housekeeping items. First, you can submit any questions by typing them into the questions pane on your GoToWebinar control panel. You can submit questions at any time, but we won't address questions until the end of the webinar. You can download a PDF of the presentation via the handout section on the GoToWebinar control panel. Don't worry if you can't find it, because the links to the handout and the recording of the presentation will also be emailed to you after the webinar. Attendees who have fully participated in today's webinar will be issued a certificate of attendance for 1 professional development hour or 1 AIA learning unit with HSW credits. You must be logged in and attend the majority of the presentation to receive a certificate of attendance. A link to the certificate will be emailed to you within 10 business days if you provided your AIA number when you registered and you attend the majority of the presentation. We will report your attendance to AIA for you. If you are currently viewing this in a group setting where only one person has logged in to GoToWebinar, you will need to email Margaret Mills with the names and contact information for everyone there with you, or she won't be able to send the certificates of attendance. Please remember to include AIA member numbers if you need your attendance reported to AIA. It is vital that this list be sent to Margaret today. The course description and learning objectives were listed in the registration process, so I won't take time to read them now. Remember, we will answer questions at the end of the presentation. Finally, let me get to our presenters. Greg Sheldon is a principal at BNIM's Kansas City office. His professional experience on numerous complex projects, his contemplative design process, and his boundless passion for the built environment have contributed to his reputation in Kansas City and nationally as a highly proficient and respected architect. While at BNIM, Greg has served as a senior project architect for the block building addition and other campus enhancements projects at the Nelson Atkins Museum of Art, the Kaufman Center for the Performing Arts, the Henry W. Block Executive Hall at UMKC, the Lewis Center for Arts at Princeton University, and expansion to the John F. Kennedy Center for Performing Arts and the new School of Music building at the University of Missouri. The general technical expertise Greg has accumulated through these and other projects is highly respected and sought after. His particular expertise in complex, high-performance facade and glazing systems has made him a practice leader in BNIM's integrated design process. In 2006, Greg was recognized as Architect of the Year by the American Institute of Architects Kansas City chapter, and in 2013, he was elevated to the American Institute of Architects College of Fellows. Our other presenter is Dirk McClure. Dirk is the Director of Business Development for Enterprise Precast Concrete's Kansas City office, where he oversees the 5-state market territory of Kansas, Missouri, Illinois, Northern Oklahoma, and Northern Arkansas. He received a Bachelor of Interior Architecture at Kansas State University's College of Architecture, Planning and Design. Prior to joining the precast concrete industry, Dirk spent 8 years practicing sports architecture. His diverse AEC industry background gives him a unique overall knowledge of the built environment. Dirk served on PCI's Sustainability Council for 10 years. Dirk is an international speaker who has authored articles published in the Construction Specifier, the International Institute of Building and Closure Consultants Interface, and PCI's Ascent magazine. Dirk, you can take it away.
There we go. All right. We are here for a combination of our passion for great architecture, our passion for the built environment, and our passion to get an AIA or PDH learning unit without even having to leave our computers. So let's satisfy those passions. We do have a lot of content to get through in a short amount of time. So I will tell you, my midlife crisis outlet's a Harley Davidson, so I'm used to moving pretty fast. So with that said, let's roll. I got to get to that screen. There you go. The attributes and benefits of precast are often seen broken into three primary categories: versatility, efficiency, and resiliency. We're not going to spend a lot of time breaking these down in detail, but you will see in the 6 examples that we go through today, several of these attributes and benefits displayed in those projects. From a precaster's perspective, we always encourage the architecture, engineering, and construction community to take advantage of and utilize the resources of your local PCI certified producers. And by that, I mean really lean into their expertise of these consultants and these companies that are available to work on your projects. I will also say for the projects we're going to look at today, every one of these brilliantly designed BNIM case studies that you're about to see, Enterprise Precast Concrete consulted on the front end of the project or is consulting on that project. And that includes the one job that Enterprise ultimately did not end up supplying precast for. So working with a precast specialist can just really help with the entire team for the betterment of the project. Whatever part of the country your project is in, there is going to be a PCI certified precaster in that area serving that territory, and they will have an individual on their staff that can help you. And so seek out those precasters with the appropriate product line, expertise, and territorial range that aligns with the goals of your potential precast project. They can help with budgeting, detail analysis, providing samples, specification assistance, making sure that your written specifications align with the goals of the design drawings and that those are consistent. They can also help with the panel layout, making sure that it is the most efficient panel layout available. In this real life example that I'll show you briefly, it started out as a masonry project, and that was not calculating out from a budget or from a schedule standpoint. So the precaster was brought in with the idea of exploring converting it to precast. It was originally worked through as a series of columns and infills, but in working with the architect, the precaster was able to make it even a little more efficient because there was some flexibility in that window placement. So they did one large 3-story piece for each of those sections with 3 punched openings, as you can see there in the bottom left. So that just provided a great deal of efficiency on that project. You can see it's obviously very ornate with the formwork and the different things happening in different planes, but this is actually a very schedule and budget driven project. And it was the amount of sheer repetition in those forms, using those again and again, that allowed them to achieve that those goals successfully. Your precaster can also help you with your certification designation for your project, what category that most appropriately fits into based on your goals of the project. And a real quick helicopter perspective here, starting from the right, the AA certification is the highest level of complexity. It is the highest tolerance for precast. These are going to be your performing arts centers. These are going to be your cathedrals. These are going to be the projects where there's going to be such a high level of expectation on the owner's part that you want to get literally as close to perfect as you can. I will say all the examples that we're going to go through today were produced in facilities that are currently AA certified. Category AB also has a great deal of emphasis on shapes and forms. You can do curved panels with AB. You can do multiple mixed designs in the same panel with AB. Category AC, that you can also do some really nice work with AC projects. We see a lot of school gymnasiums and auditoriums classified as AC. You can do thin brick set into the panels. You can do form liners. You can do exposed finishes. You can do more than one finish in the panel with the same mix design with AC. And then with AD, the tolerances loosen up a little bit, and those work with gray cement instead of white cement. So while these projects don't have to be painted, they're typically going to be painted. So these are your warehouses, these are your big box stores, although in some cases we do see projects in that category that still go ahead and go with the AC classification. So that's the quick helicopter perspective. Another thing that people that do a lot of precast procurement get very savvy about is getting the precaster on board as early as possible. They realize the advantages of doing that. You not only get in the precaster schedule, but the precaster can come on along with you as a design assist partner, help with the detailing as the CDs are being finished, and can also commence a shop drawing process. So there's some overlap there. It allows some time saved so that the owner can get into their building sooner, start paying off their loans. There's basically two ways to achieve that. One is to budget the project and negotiate with a preferred precaster. On projects that don't allow you to do that, you can issue an early core and shell package and get bids on the early core and shell package before going into the CD process. So now I'm pleased to pass it over to Greg Sheldon. It's not our first rodeo. Greg and I have presented together for AIA conferences, DBIA conferences, PCI conferences. I will tell you, he is the most fun person to present with. He's a material expert. He is a great storyteller. So very pleased to have him here with us today. Thanks. Take us away, Greg.
Thank you, Dirk. That was very kind. Well, I've got a series of projects here. I think there's 6 total that we're going to go through in varying degrees of detail. And this is the first one, the Kaufman Center for the Performing Arts here in Kansas City. We did it with Moshe Softy's office. And a significant thing in this image is notice, and we'll see if my little cursor will find it. Look at some of the buildings in the background. Jackson County Courthouse. Then that's at the far right. Then we have the City Hall of Kansas City, Missouri. Then the tall structure with the pointed top on it, the Kansas City Power and Light Building, and lurking down low to the left with a little pyramidal roof is Municipal Auditorium. What do they have in common? They're all built out of classic buff Indiana limestone, all built in the 1930s. That became then a design precedent that we were looking at to try to make this new facility fit into the Kansas City skyline. And here's a nice image. You can see here, here's the tone that we ended up using in the concrete to work with that buff Indiana limestone color. So we received samples, and Moshe and I walked over to the Municipal Auditorium, held them up, and he said, it's that one. And we made our selection, and on we went. Also, as part of this is a massive steel frame building, and enclosing it quickly and efficiently was very important. There couldn't be a lot of time spent doing that. So using an insulated precast panel to put the entire envelope up simultaneously was quite desirable. So this is the panel that we came up with, 5-inch interior wide, 3 inches of insulation, and then the 3-inch face piece that had that architectural color to it. Now, related to this, I wanted to talk a little about sort of our concept for an insulated precast panel, the way I like to think about it as part of the building envelope, and you'll see that repeated in these other projects. The interior wide is the structure, and sometimes it's composite with the exterior. We consider it the air barrier. One advantage of precast, unlike cast in place, is you don't have form ties, you don't have cold joints. Typically, the curing minimizes the amount of shrinkage or cracking and things that you get. So you get a nice airtight panel. In the same way, it can actually make a reasonable secondary drainage plane. It also, is noted, actually will provide the vapor retarder function in the envelope assembly, as noted at the bottom. What is shown here at 5 inches is essentially a class 2 vapor retarder. It would be rare to have to further evaluate and look at supplementing vapor control with a panel like this, perhaps if you go far enough north with a humidified building, an example later. And also very important, this interior wide we look at to provide the thermal mass for the wall. Once you get up to about 3 inches of normal weight concrete, you meet the code requirement for 35 pounds per square foot. That lets you do good things with your insulation, which is the next step, and well, 2 steps. As part of that, then, once we've allowed that interior wide to provide all those basic envelope functions, that sealant shown there, the interior seal, we typically do a 2-stage joint, that completes the barrier of the assembly. So that interior wide with the sealant joints creates the building envelope line. You can see the envelope line noted defining interior from exterior, and we approach it that way as we go through detailing and joining with other systems. Then the insulation plane, this one shows 3 inches that was used at Kaufman. One of the nice things about insulated precast is that typically when it's a mass wall, the R value requirements are relatively low, like in the lower teens, depending on what climate zone you're in. And it's very easy to then get a significant insulation value, significant enough that one of the strategies we sometimes like to use is when you think about a LEED accredited building, you get 19 points if you can reduce your energy use by 48%. I like to take the attitude, then make the envelope do its share and reduce heat flow by 48%. So simply, like in this case, if we bump the insulation up to 4 inches, we would actually double the thermal resistance to what a baseline code model would have been and significantly improve the performance. Also note the wive connectors that are shown here. Those are very important in the assembly. We prefer to use non-metallic connectors, obviously, to minimize thermal bridging. At Kaufman, they were actually steel trusses, so that which was what was being used at the time. That was engineered as a non-composite system, but it's hard for me to imagine that with the steel connectors, it didn't actually function that way. So then this insulation we're kind of thinking of as exterior, even though it's in the panel. And then the final layer is the exterior wide. And it's going to be maybe composite with the interior. It essentially is kind of like a rain screen. It is face sealed and it brings the architectural finish. So we tend to think of the wall not too much differently than, say, a brick cavity wall or some other types of assemblies where we have these different layers within the one panel. More on that as we go through. Then one of the important things is how do you interface these panels with other systems? For example, on Kaufman on the left, because of the fact it was non-composite, we held the exterior veneer up at the base. You can see the 2 red lines on the upper left. I think my little cursor, yeah, there we go. And what that allowed us to do is we ran the building waterproofing up what we were calling that barrier face for a constant seal, and then put all the foundation insulation in plane with the insulation in the panel. On the right is the interface with the roof. You can see that massive steel frame that we were trying to clad in one pass with the insulated panel. That's corrugated metal is the decking. Notice what they're putting on here though. This is a standing seam metal roof. It's not the finished roof. It's the air barrier, secondary water barrier membrane for the roof. And we're sealing it with an ice and water shield to that interior wide of the precast. The same trick was done here at this side, where the architectural wide was held up and then the building was being sealed with the same membrane from the metal panel to the face, the interior face of the concrete. So we get a complete building envelope line. And then here it is in its completed form, the finished roof with Zahner sheet metal provided that you can see in that wonderful warm glowing tone of the concrete. And then this one, this is the south facade of the building. It's got the cable supported glass system, probably the most complex facade thing I've ever worked on. But very interesting was this geometry was defined. This building is totally geometric. It's one of the ways Moshe likes to work. The roof is a torus in its shape, and the south facade is a tilted cone, which was a challenge for everybody on the team.
Shifting from an architect back to a precaster's perspective here momentarily, the structure itself presented its own unique set of challenges. There are very few right angles in this building. It was also the first project that this precaster performed BIM modeling on, something that's obviously standard practice now. This project goes back a number of years. So as Greg just mentioned, the gentle curve here that you see at the lower level, it's made up of a series of elliptical shaped precast panels designed to match the floor plate of the building itself. So this was really a key challenge because the irregular curve shape typically would have called for a great deal of additional formwork, which would result in additional costs for the project. The precast producer was able to use a single form by manipulating the work point, rotating the form, using specific portions of that form to cast each individual component. And then those curved shaped pieces were shipped out to the job site in specially made racks to avoid damage. So, I mean, obviously the end result, the entire building, it is an internationally recognized performing arts center. And we're not exaggerating to say it has played a key role to bringing arts back to the Kansas City community in full force.
Okay, then moving on to another project. This is the one in the series that we're going to take the deepest dive into because it's really an interesting case study. It's the Henry W. Block Executive Hall for Entrepreneurship and Innovation at the University of Missouri, Kansas City. Nice name. We did this project in collaboration with Moore Rubel Udell Architects and Planners. You notice the color, the coloration on the exterior of the building, and what was the genesis of that idea was it's a largely masonry campus at UMKC. And the new building is located kind of in the middle where it's labeled here, and it's in the middle of a complex where the existing School of Management is here, which includes what was known as Oxford Hall, which you see over here, the old Shields residence, a 1909 Kansas City mansion that was done in a deep red brick. And then at the extreme north is the new Student Union, and it's done in a buffy tone brick. And we were thinking we wanted to work in a masonry idiom, but how did you work within the context of these two things? Well, one of the ideas that was generated, this became a precedent for, where you have the building on the left that's been done in colored terracotta, and it's intended to sort of simulate or harmonize with the existing historic structure on the right-hand side, not by the patterns and the line work, but by taking the colors of the materials and reusing them and reinventing them in kind of a new form. And we thought that could be a really interesting way to approach the design of this project. So we did what architects do, as you'll be seeing. We went through and studied what would it be like to take that coloration variation and blend the intensities differently so that at the south end, at the red brick building, you had a deep red intensity. And as you move to the north, adjacent to the yellow buffy Student Union, you got the lighter color. We overlaid it then on the facade, as you see there. Did all the process that you do. We took all the terracotta out. The university looked at it. We picked all our colors. And the plan is to use a terracotta rain screen system. This one you probably recognize as being by NBK. It's a great system. It's one that we do like to use. But one thing about this is it's a slow, expensive build. You notice you have to stand up the stud. You have to put up the sheathing. You got to put the air water membrane on the sheathing, put in the horizontal girds, add the insulation plane, put in the vertical girds, clip on the terracotta on the outside, and then put in the drywall on the inside and finish it. It's a great system, but a lot of parts, it takes time, and a lot of trades have to touch it. There was a challenge, the budget and the schedule. I doubt anyone on the call has heard this before, but we were actually, it seems like $357 a square foot, even at that time, wasn't a great budget to have to work with the project, despite the generosity of the original donation. And worse, notice the schedule. Total construction from when they could actually get on site to when the building was to be occupied was 18 months. So a priority became, how can we build it more cost effectively, and how can we build it faster? What we decided to do was to take the terracotta, but to see if we could use a panel, not unlike Kaufman, and use an insulated precast panel and cast in the terracotta. Fortunately, NBK had done that before in Europe. They'd done, I think, one project in the United States uninsulated, and bless Dirk and Enterprise, they were willing to work with us to try to see if they could make it work. So this is the panel that we actually developed. It's a 4-inch interior wide, as discussed, then the 3 inches of insulation. This uses the carbon cast, the fiber composite connectors, as opposed to the steel truss, which is much better thermally. And then the architectural exterior wide of the concrete has the terracotta cast into it directly. And note, the interior face of the interior structural wide was to be sandblasted to make the interior finish. So this panel could provide the complete wall assembly. So here it is in plan. And so while this panel was while Jay Dunn was erecting, the contractor, the structural frame, Enterprise could be making the panels. They would stand up the panel, and then you see this primary sealant joint, which we talked about in the previous slide, which we consider as the one that defines the building envelope. Once that is in place, the building is enclosed, it's watertight, and interior finish work could begin. Only things left to do with a cosmetic seal inside where it was needed and a finish seal on the outside. Notice the semi-rigid fiberglass. This was in the days when everybody was starting to freak out about NFPA 285, and our code consultant said we had to cover the edges of our foam plastic insulation, even though they were encapsulated in concrete. But it's actually good because it maintains the insulation plane. And back on the theme of integrating with other systems on the building, this is how we integrated the fenestration. We used a curtain wall system for performance, put the structural portion in plane with the structural withe of the precast. Notice the primary seal line for the precast coincides perfectly with the air line of the aluminum glazing system of the curtain wall. Here's that nice insulation that was stuffed in to protect the edge of the foam plastic, but also provides continuity to the insulation plane of the glass. So you notice we have a complete thermal line here with no thermal flanking, and then just a custom snap cover sealant, and the total facade is done, finished on the outside, finished on the inside. It was a huge boon to getting the building done within the 18 months that was available. Some kind of pretty pictures. Here's the old, this building is the addition onto the old residence that was done in the 80s. Embarrassingly, I worked on that. That's right when postmodernism was starting. But you can see the effect of the red on the south side of the building. Here's the north side where it has transitioned over to the buffy color to work with the student union that you see on the right. Here's one of the corners of that right through here as the transition goes. And here's a nice view on the interior where this is a classroom, and Moore Rubel Udell was a huge help on designing these classrooms. They have excellent expertise with that. Notice the precast, that is the finish. So that panel provides the exterior finish in the form of the terracotta and the interior finish for the all of the classrooms inside the building. And with that, Dirk is going to talk a little bit about their experience with putting this together.
My favorite thing about terracotta remains that you can spell it 3 different ways and still be correct. That's a big one for a guy like me. This is actually one of our more decorated projects in terms of the amount of recognition it got, both from the AIA and PCI with various awards. It was the first of its kind in the United States. Terracotta had never been cast into a large insulated sandwich panel like this. So a lot of research went into the front end of this. We looked at things with our internal engineering group like coefficient of friction, elasticity. You know, we knew these panels were going to bow within a certain tolerance. Could the terracotta handle that? We did freeze thaw testing, pull-out testing, and to the credit of our friends at NBK, when the German standards did not match up with some of the American standards, they elected to do some more testing just to give everyone a greater comfort level with this project. And once we were convinced this was viable, we rolled up our sleeves and went to work. This was a 5-color random pattern. They were 6-inch by 4-foot long strips with a shiplap joint. You can see there at the bottom, and we actually maintained that shadow so that it looked exactly like it would have if it was the rain screen system in the steel frame with the air barrier and the conventional construction. And with the joint sizing and everything, we kept it exactly the same. This is Gary. He's our Omaha plant manager. He's what I call a servant style leader. He leads and he manages, but he's not afraid to really get in there and lead by example. He's actually laying out the first few terracotta tiles for the first panel. And from our standpoint, there was nothing random about it. B&IM told us where they wanted each color to go, and they had a very good reason for doing that. So we didn't take any chances. We had color-coded instructions in our Omaha facility. Here you can see this 12-foot wide panel with a series of 4-foot wide terracotta strips with a block out opening. Then we put an adhesive down to keep the concrete from seeping through, put down the first level of reinforcing. This was a mildly reinforced job. We did not pre-stress like we do on most of our projects. That had to do with the research and wanting to have a fully composite project, and we just felt like a mildly reinforced project would work the best in this particular application. Here you can see they put in the lifting loops that are going to be used to roll and to handle the panel. And then they put that first withe of concrete, poured it into place, and then smoothed and vibrated it into place. That's a critical step so that everything, the mix stays fluid and everything settles properly. Here you can see them putting the insulation into place. And as Greg talked about, this used a carbon fiber grid with an epoxy resin. It sets down into that portion of the concrete while it's still wet. And the part that you see up above there will actually set into the top withe of concrete, which will be the interior face of the building. So then that reinforcing is put into place, and electrical outlets are placed. That's a big benefit of precast, is you can cast electrical into the interior withe and have nice flush outlets. And then that top withe of concrete was poured and trowel finished. You can see a little gravity connector up there in the top right-hand corner. The second day, they come in and they've cast cylinders with the same mix under identical circumstances. They put that in this compression chamber and they break it. That gauge measures the strength. That's how they confirm that the product has made strength and that it's can be extracted from the production bed. And then it's technically still curing for another 28 days. So they do a second test later to confirm that it exceeded 5,000 PSI in overall strength. That's part of our PCI certification. We have that internal quality control testing. So then that second day, they pull off the side rails. They lift up the panel with an internal rail system, and then they roll it out into the yard. They store these vertically in racks that we call toasters that just helps to take care of the panels, and they're washed and sent out to the job site. The site itself, it was a 4-story cast in place building. So this was a non-load bearing application. It had a little atrium space in there, which was a key design component. Here you can see those panels going into place from the interior. And down at the bottom, you can see those gravity connectors that you might have remembered seeing on the other panel. In this case, there was a raised floor. So we had the luxury of just being able to bear down on the slab. Sometimes we'll actually cut into the slab to conceal those larger connections. And there you can see it starting to go into place on the exterior. And just working our way around the building here. Our construction partner, J.E. Dunn Construction, also self-performed the install on this project, in addition to being the contractor. There you can see outlined the size of one of the panels, what the panel looks like in terms of size. And I remember one day standing on the job site here, looking at this and thinking, oh, so it's darker on some elevations than it is on the other. I think they're trying to create an effect, maybe like a shadow. And then I stepped back and I looked a little bit more and I realized you have this traditional masonry campus, and on one side of the campus, you've got brick buildings. To the other side, which would be to the left out of this photo, they're all limestone buildings, and this is a dividing point on the campus. So they have kind of basically paid homage to what has happened on the campus before they came with this building in just a really elegant and beautiful way. And that was with a larger concentration of reds on the 2 elevations that face the brick side of the campus, a larger concentration of cream colors that face the limestone portion of the campus. And it was really fun to have that moment. I'm a recovering architect, to see that and to get the concept and to find out that actually was the concept for the project. And then this was the north elevation. And here you see some completed photos. There was a corner piece that was field installed on the edges. The rest of the terracotta was all cast into the precast ahead of time. So in this case, this conversion was a big success story. I mean, you came up with a system that ended up being less expensive, it went up quicker, and it performed better thermally. So it was a real win-win-win. With conventional construction, you have a lot of different trades, a lot of different schedules, a lot of different people on site, a lot of coordination, some complex construction methods, as Greg was talking about earlier. With precast, you've got the consolidation of those trades and a certain efficiency that it can add for the right kind of project. So it's always really exciting to be first. You know, somebody was the first to do thin brick into precast panels. Somebody was the first to do an insulated panel. This was the first large insulated terracotta project in the United States. And one little brief rabbit hole I'll run down here. You're not going to see examples of this in today's case studies, but one of the new things now in the precast industry are thin architectural insulated cladding panels. And it's something that we're really excited about as an industry. A lot of precasters offer a version of this. What would traditionally used to be a 4 12-inch panel can, in a non-load bearing application, can be done with a 2-4-2 panel. So you're cutting the amount of concrete and the weight of the panel essentially in half. So you can you're using less material, you can get more panels on a load, taking it out to the job site. They can size the crane down because they're going to weigh less. This system, you know, can weigh less than a conventional brick system once, a masonry system, once it's all said and done. They can also right size the footings and foundations for the lower weight system. You don't hear precast and lightweight a lot in the same sentence. So this is something that we're pretty excited about as an industry, and I encourage you to reach out to your local producer if you think it might be something you're interested in.
Well, thank you, Dirk. That's a new system we're interested in learning about and starting to use. Okay, I'm going to kind of quickly go through a couple more here just to get some examples of other ways we've used precast. This is University of Missouri in Columbia, the Siegfried Music Center project. This was one where we actually started, I'm going to skip back real quick. We actually were thinking originally of the precast on the right and that bar, as we called it, being a different material. And we looked at a lot of different materials, but the usual story with sort of the schedule, the budget, things like that, we very quickly locked into using precast for everything. Typical architectural thing. Our building is over here on the left-hand side. Over here, and the old original student union at the University of Missouri in Columbia was over here. And so we took some of the features on it in terms of the composition, the proportioning, these kind of rotated column-like elements in the facade, and started to look at ways to sort of incorporate that compositionally into the new building using the precast. We also looked very closely at the existing materials of the student union that had a beautiful bush hammered stone. And we looked at a lot of different precast samples to look at that and find some that we thought would be consistent and sort of a piece in terms of color and texture for our new building that would match the student union. We found a really nice panel here, the Reckley panel that you see shown here, that had a really nice texture to simulate the bush hammer. And we used that on the body of the building that we kept the real smooth, kind of flat planar facades, but then created the bush hammer texture. But then we wanted to make the other facade a little more monumental, just using smooth. But what was important to us was to try to make, the jump in scale from the fine texture of the bush hammer to a large monumental scale like you see here, and to make these strong forms that you see. And we were really anxious about trying to make this leading edge as crisp as we could. And that kind of became a challenge. The simplest thing to do would have been to do what I've shown in red here and make a donut shape kind of a panel with the window in the middle, so you could just erect one piece. But we were desperate to get this sharp, crisp edge. So we actually designed in the construction documents this 3-piece panel, a lot more erection involved in it. We did use the insulated panel, and we wanted to get as much relief to that projection as we could get. But working with the precaster, the most we were able to get with the insulated panel was the 6-inch projection. And here's an example then. This job was actually done by Mid-America Precast in Fulton, Missouri, and this is in their shop. And here's one of those center pieces, and you can see that really nice crisp edge. And here it is up on the building. And we're really glad we did push that, because the idea of having that sealant joint on the leading edge, a joint like one of these on this leading edge, just wouldn't have felt right. So we were able, in this case, to work with the precaster and really push that along. We also did another interesting thing on this project. We used the insulated precast structurally by pre-stressing the panels. Here you see the drawings for putting the tenons into each one of the panels. We did maintain some insulation in the panel, and they were used to form the large instrumental rehearsal room for the building. If you look on the left, you can see these full height insulated precast panels that have been pre-stressed. You see the anchor connections at the bottom, the weld plates to the foundation, the south wall with the windows, and then you can see the crew up here, and they are directly attaching the bar joist roof structure to the precast. So it is the structural element for that room. And here's that room finished. It really turned out to be a nice room. You can notice the building opened right as COVID started. You can pick that up in this picture. So another building then, moving on. This was a fun one, the Kirk Family YMCA Community Center, also in Kansas City, Missouri. It's an interesting old building. It had been there for a long time. It was built as an Eretz Shrine temple. It was a radio station, the home of the Lyric Opera, home of KMBC TV. It had done a lot of things through the years. The new concept was pretty straightforward. It was going to become a YMCA, literally cut out what's there now, leaving the historic facades, and drop in a running track, a basketball, volleyball court, exercise areas, a swimming pool, an auditorium, and sit those in behind the facades. We did what architects typically do. We came up with a really bold, aggressive kind of west elevation, lots of glass, sunscreens, things like that. The owner said, make it more historic. So here comes our friend Precast again. We used it for that reason, but also for several others. We were looking for a very durable building for the downtown site and for the kind of high intensity use interior. Precast made sense. We did want to work with the stone-like appearance to make it work well with the existing building. We also ended up using a complete precast structural system, not just the cladding, partially because of the corrosive environment induced by the pool. And we also used hollow core planks for the floor slabs to keep the thickness of the floor assembly down. So it was an entire precast project. We did what architects do. We had analyzed the facade, base, shaft, capital. We looked at all the regulating lines that went through and organized the old facades. Very importantly, we looked at the materiality, the original masonry construction, and looked at textures and colors of precast that might be able to emulate those existing materials. Here's the new design, and you can see now here the building turns the corner, but then the new building starts to take on the character of the original, using the precast to simulate the original masonry. Here's another view, and then as it turns across on the north facade where it looks down on the outdoor fields, went to something much more contemporary. Here's some images of the construction. You can see at the far right, there's the original historic building. Here comes the new precast being set in place. You can see the beams, the columns are all precast. Here's one of the new panels being put into place. I think we used a 444 on this one. So it was a case of getting the double, having very good thermal performance. And we also sandblasted the interior of these panels as well. I like this one, this filigree. It's on the east elevation where we uses the concrete just to create very much like what was originally intended for the west side. That would be infilled with glass. And once again, you can see the running track hanging there, but you can see the total precast structure in place. Here's a nice interior shot then. This is one of the workout areas, running track hovering above. But like on Block Hall, notice that wall. That wall is the precast. So the precast is providing not only the exterior finish and the thermal control and the control layers of the building facade, but also the interior finish. And here's another nice shot that's got both an interior and the finished product for that exterior filigree.
Yeah, so a notable architectural feature is obviously that those 2-story windows that you see on the right. They wash the spaces with light, and they're accented by these custom architectural precast concrete fins. A lot of strategic planning went into those large fins to make sure they worked from a reinforcing standpoint, from a weight standpoint. We looked at the reinforcing and the insulation infill in a lot of different ways, and obviously B&IM wanted to do certain things with them aesthetically, make them a certain size, a certain length, and we worked all that out on the front end. And the articulation of just these custom formed panels really allowed for a really nice modern interpretation of the historical cornice and tablature and colonnades that you see on that north and that east elevation. And I'll just double tap on one of Greg's points, and that was, I thought it was a really nice touch the way they sandblasted and exposed those interior precast walls, so you can see them along with the columns, the beams, the hollow core. It's just a great honesty of materials approach.
And that's the concluding photograph for this particular project. And notice how seamlessly it is. You can see over on the far right with the smaller windows, the original structure. Then here comes the new precast structure with all the different features done in precast to simulate the old original facades. Turn the corner to the north to the more contemporary view. Another project that really turned out nicely. Last 2 projects that we've got, I'm going to go through. One of them is under construction and one of them is on the boards. And the first one is under construction right now, another school of music. This one, the Glencorf School of Music at the University of Nebraska in Lincoln. And for this facade, we wanted very much to try to get more depth of profile than that 6 inches that we got at MU. We didn't feel it got quite enough shade and shadow. So one of our major agenda items here was to do that. And we started looking at a whole bunch of different materials from GFRC to UHPC, all these different kind of panels. But the things we were having to do to frame and shape these eyebrows, these hoods around the window, it was becoming really expensive. And for a variety of reasons, we decided we should go back to precast. And thankfully, Enterprise was willing to work with us on it to help develop it and to fit the project into the university schedule. They were originally totally backlogged. So this was kind of the image right here, this rendering of where we started. And then you can get an idea of the depth as this looks down what was the west facade of the building in this rendering, and trying to create these shading devices, these sculptural profiles on the facade of the building, and how deep could we get it became our internal discussion. Well, you can see we did all kinds of things on the left. We got all the layout right. We understood the dimensions, the proportioning, how the line work went through the building, sorting all that out. But we made a switch then here. What we found was that we simply couldn't get the depth of profile we wanted and maintain an insulated panel. The panel would be too heavy, and they just simply couldn't get it out of the form. So what we ended up doing was we went to a solid monolithic panel. It's basically 8 inches thick, but notice the projection. Instead of the 6-inch projection that we were able to get at MU, we could get a full 1 foot of projection. What we ended up doing though then was insulating the inside of the precast with spray foam insulation, 3 inches of spray foam polyurethane, again with a mass wall, extremely good benefit. And remember, whenever you put the spray foam on the inside, you have to have the thermal barrier, which is shown here. And we did analyze this one pretty carefully. Another school of music, it is humidified. We're holding 30% RH, 68, 72 degree temperature range, meaning we're going to have mid 30 degree dew points, which is risky because the exterior ASHRAE temperature in Lincoln is -7 and the university says designed to -20. So we believe we've got it to work out well. Unfortunately, one of the challenges with the interior insulation approach that we weren't able to do what we did on Block Hall, we couldn't get the thermal plane of the glazing in plane with the insulation for the precast. So there is some thermal flanking. You can't really see the nuances in there, but we actually have done some things to bring insulation through and try to join those planes. But that was one of the challenges. But we were able to get the 1 foot projection. Here it is under construction, and you can start to see the drama that goes with that. You can see how those deep shells, and this one I really like this. This is a shot right up the facade, and you can see those hoods, those window shading elements as they project. I particularly like this one. This is starting then not the fine scale like we were doing like with the bush hammer and the form liner, but this is taking precast to a more monumental scale. This is more Marcel Breuer-like to me. It's got a lot more body, much more dynamic for the scale of the building. And this, when there's that shot down the west elevation, and you can start to see on each one of those things, there's portions that are in sun, portions in their shadow, and you're starting to get that articulation. I particularly like this shot under construction, and notice all the shade and shadow and how strong it is on that facade. That's what we were after, and we were able to achieve it. We did have to go to the interior insulation, and as I think most of you know, especially as you go north to zone 5 and things, you just can't do interior insulation with anything but the spray foam, because bad insulation and whatever you cobble together for an air barrier just isn't really going to work. One thing I also wanted to mention on this project is one thing that's a huge agenda to B&IM architects is our sustainability and reducing carbon. And one of the challenges with concrete, with any concrete, is carbon reduction. And we worked with Enterprise on it, and precasters, bless them, are reluctant to change things, especially in architectural mix, because what's a new admixture going to do to the appearance of a panel? How's it going to work over time? Without doing a lot of testing, it's not a change they want to make. But what we found on this one is a colored panel like this one that's 8 inches thick and even thicker, up to 20 inches in places. They pour the colored concrete first and then fill out the pour using a conventional concrete mix, and typically trucked in by a transit mix from a ready mix supplier. Those people are getting more and more and more into carbon reduction. And so we were able to work with some of those suppliers and improve the quality of each one of the panels in terms of carbon content by working with the producers who are supplying some of the concrete. And this is an agenda item for us that we're going to continue on with strongly in the future. Last project, just real quickly, just because this is on the boards right now. It's a school, a middle school in Oklahoma City, and it's an existing building right in the middle that's having two huge wings added onto it. And we're doing this with Butzer Architects in Oklahoma City. I forgot to mention we did the University of Nebraska project with Sinclair Hilly. I think it was on the slide. And this drawing is actually showing the precast and what can be done and where will different textures and colors be used to try to take what could otherwise be really expansive, boring facades and give them life or articulate them. Another thing that's interesting, is up here in this corner, notice this area here, this is a gymnasium area. It's actually being built to FEMA storm shelter standards. So these are very robust 8-inch precast panels. We're going to have to use the same strategy of the spray foam insulation on the inside. The panels are too thick to be able to do insulated precast here. This is going to be much easier. So now we're down into zone 3 with an unhumidified building. So we're basically home free. But what we have gotten into then is we're trying to use fairly flat panels and enliven them, not with the bold moves that we did in Nebraska, but to start to do other things with the panels in terms of color and texture. And I think this shows you an example. Notice the fine filigree that we would get from a form liner that you see up above, and again, form liner and different color down below. This project is just finishing design development. And in fact, I think our team is wrapping it up this week. And it is then going to go out, and they are going to put it out for a design assist bid with the precaster. And I think it's going to be an important thing. And this is the kind of last slide. It's boring, but think about this when you look at it. Look at the beautiful interplay of the panels, the joints, and the windows, but Dirk is probably shivering as he looks at it. Think about casting, erecting, transporting a panel with those kind of profiles in it. I've been talking with our team about, okay, first thing that's going to happen when the precaster comes on board is we're going to have to talk about what is realistic and what isn't, and how are we going to panelize this building, which, as Dirk is saying, is one of the advantages of bringing on someone. And I think I'll kind of end on that note. I think while I was giving from an architect's perspective, and we, as you can hear, look at all kinds of materials. I mean, glass like is my favorite thing, and all these other materials that we use, rain screens, all these different things. But precast is an extremely good system to have in your back pocket because of the fact it's a speed of erection, it's cost effective. We didn't say it, but on that University of Missouri project, we reduced from the rain screen to the in place by 40% the cost. It's very cost effective, can provide a great envelope with a lot of flexibility in it. Yes, there's carbon issues that we're all going to continue to work on. And one of the assets, though, is that if you get into a project like this, every one of ours that it has really good success, we got early engagement with the precaster. So if you're looking at a precast project, it isn't just the architect's perspective, it is the precaster's perspective. And the sooner you can engage a PCI certified precaster to help with your project, the better off you're going to be. And that, we're right on time. Can you believe that? Woo! So we can now open it up to questions, which I believe will be passed through to us from the chat. So
Yeah, so thanks, Greg and Dirk. Let's start answering some questions. Just as a reminder, you guys can still submit questions through the questions pane in your attendee control panel. The first question that I have for you says, in a sandwich application, how does the drainage plane work?
well, what we usually do is I describe the two-stage joint. And the two-stage joint, there's the back seal and the face seal. And at the bottom of the panel, we'll usually loop the back seal out to the face and leave the equivalent of a weep hole. So that drains the void. Speaking of the so-called a drainage plane, as in the face of the panel, it really doesn't do that. We treat it as though it's there. If water gets back there, it cannot penetrate the inner wide to move into the building. But no, there is no drainage plane. We have toyed with the idea of talking to a precaster about, well, one, different insulations. Mineral fiber is one of our favorites, but it's not being readily used in precast at the present time. It does drain better, or incorporating a thin drainage plane material. But in all honesty, the face seal of a precast is such that we don't think that's a major issue. So we drain the joints and don't worry about the face behind, the outside face of the inside block.
Okay. The next question says, I'm going to try to interpret this, but it says, how do you field / QA QC on deeply set primary sealant joint in the two-stage system?
That's a very good one, and mock-ups are very important on that. The Kaufman Center example I gave earlier, we actually specified for them to stuff end seal into all those joints, because they could take a tool, they could put it in there, and they could roll it back into position, and we felt that would be an adequate seal at that interior face. The subcontractor who had the scope of work wanted to wet seal it, and we said, gosh, that looks hard, can you do it? Well, they did a series of mock-ups where they would roll the backer rod into position. They had a tool and they correctly position it. And then on there, they had those pumper guns for the sealant, not just your little caulk tubes. And they had a nozzle for it. And they would insert the nozzle into the joint and then run it through over the backer rod. And they demonstrated to us that they could do it effectively. And that's what they did. And then that's what we've used on projects since then. We didn't expect and evaluate every one of those joints as we went through it, but we did find a mock-up, get it done, and had an example that they could do the work, and hopefully they did.
Yeah, so with precast, you're looking at things differently. It's a face sealed material, so the key really is to have good joints and a good moisture penetration system. I know we promised to get into some lessons learned. Another point about the joints is, and I don't think we ever ran into this on a B&IM project, but sometimes we'll do a dark colored precast and then the joint sealants will come along in a separate package and they'll do a bright colored joint, caulk joint, and it'll kind of pop. So it's really something we encourage the design community to look at, is really the color of those caulking joints, and make that match your precast as much as possible.
Okay, just a housekeeping thing here is we're about at 1 o'clock. Greg and Dirk have agreed to stick around for a few more questions, but this satisfies the requirement for your certificate for the day. So if you want to stick around, I'll ask a few more questions. So here's the question. It says, with the second building at UMKC, were there any repair concerns with the terracotta intricately cast in the concrete? Example, if the terracotta were damaged, how do you replace one of those?
Oh, there were all kinds of concerns. I mean, that really wasn't a, do we get to do this project sort of question as much as a, do we want to do this project? So, I mean, we did research, we did mock-ups, we went through quite a process, to convince, ourselves and everyone else that it was viable. And it ended up really being, a trendsetter. A lot of these have popped up since on the East Coast and the West Coast and all over the United States. We did have a few broken pieces. When you have a broken piece in the panel, it can be just through a patching process, remediation, it can be replaced. But we had, I want to say very few, if any, that we actually replaced on site.
We kind of rationalized it. It wasn't much different in that context than a thin brick system that's cast into precast. If one of those gets damaged, it has to be chipped out and then adhesively reinserted. And that would be the reality of what would have to be done with the terracotta piece as well.
Okay. Next question. Are you using different colored aggregate in conjunction with sandblasting to achieve different finished colors without using mixture tinting?
We have. We didn't show a lot of examples today, but one of the things we often do is that just taking the mixture itself, the basic mixture, and playing with the aggregate, the fine aggregate, especially the coarse aggregate, and using a lot of different colors or using different colors, and then using a retarder finish or a deep sandblast finish. Usually an acid etch wouldn't work, but trying to expose the aggregate through sandblast or a retarder and letting that bring the color to the forefront. We have done that on other projects, but we didn't show any examples of that today.
In some of the projects, for instance, one of the ones we talked about, the Kaufman Performing Arts Center, Greg pointed out early in the seminar about how all the buildings downtown, there were so many examples of limestone buildings. A lot of thought and effort went into the tonality of that precast, the color, the aggregate. A number of samples were done just to kind of hit that sweet spot in terms of both what aggregates were used and how it was exposed with a degree of the sand.
All right, we'll finish with this question. It's kind of a two-part question. I'm gonna lump two of them together. It's about thin and standard panels. And it says, what is the main difference between thin and standard panels? And the part two to that is, do you lose any inherent precast benefits by using a thin wall system?
Well, the main thing that you need to watch for, I'll address the second part of the question first. One, our thin panel, which we call the E50 IAC panel, it is for a non-load bearing application. So you're using it for cladding. You're not taking load. The other thing to think about is the reveals. We're not talking about 1-inch reveals. They need to be very, very narrow because you've got just 2 inches of concrete there, not as much meat on the bone. So yeah, you're limited just in terms of it's not load bearing and it's not, you can't go really deep with your reveals. Your benefits are less concrete, less material, less weight, less crane size, less trips to the job site, and then being able to right size your footings and foundations. That's a big one.
Okay. Well, let me finish by saying thank you, Greg and Dirk. I thought the presentation was great. And thank you to everybody for attending today's webinar. You should receive an email with a link to your certificate of attendance within 10 business days. Thanks again for joining us and have a great day.